Now you know that you've run all your analysis is successful and everything has run okay, your design is okay. You can now send it back to the detailed template where you can furtherly make some a detailing. I hope this helped. So I want to take it down to detail to show the detailing of all we've already reinforced. But before you do this, that's something you need to consider, when you're running your model this way. Because in as much as this pass, that does not mean that you could not change, you cannot change some other reinforcement. So for you to understand that, let's click on the beam, and let's go to our active story, and we're going to do our interactive design. You can see this is what we call, these are all the analysis for all the story. Now I activate the story for story 3, all the beams for story 3. These are all the beams for story 3, and you can see the design status showing that it has all passed, and our utility ratio showing that it is sufficient. Mind you, for any reason you are going to see 1 here, then that means that that design has to be rechecked. Please always put your eye here. So you can see the design status is okay. So what we're going to do is to go to the interactive design. You click on interactive design, you know, interactive design, and check all your members. You can see all your members. This is how the detailing is going to be. It's telling us we should design with 2y16, or this is the top bar and this is the bottom bar. You can see the indication showing the top bar at this area. So if you look at this, you can see this row for the top bar. Look at the next row for the support top bar. So this is where you can, at the joint, where you should support the top bar at those joints. So you can see support, additional support if need be. So looking at this, this is your bottom reinforcement, and this is your bottom bar and your bottom support, and the link is the stirrup member. So you can see telling you should put both 2 or and 2 at the bottom. So this design is okay. So I think at the roof you don't really have much, you know you don't really have much impact at the roof. So we can go on the other beams on the first floor and the second floor, where we have, the slab load distribution down to the beam. So let's go. So this is our first floor. So on the first floor, we're going to click the beam, and you right click, not section table. You go down to your beam reinforcement design. You click on the beam reinforcement design, and you're going to see your design status. You can see all our design status are all green, showing that this is a wonderful and amazing design. You can see all wonderful and amazing design. So since we have our utility ratio showing 1 here, we have to pay very attention to this design, to this beam. You have to pay very close attention to this beam in detailing it. So let's check our addition, because for the plan to show you green mean it's a good design does not mean that it doesn't need a modification. There could be a scenario whereby there could be a modification such that I don't want, maybe in a scenario where you don't want to use um, the, the, a reinforcement. You can see here it's showing 16 all through, and here we have 20, 2y20 and 2y25. I don't want it. I want the design to flow with 16 mm. So the 16 mm could be affordable, because in doing interactions of the design, you're mostly looking at the challenge of costs, how you can get a suitable design with a little cost. So you're going to be looking at the parameters, because if there is any indication at this, you know, area, this is the area, and this is your top bar, this is your top bar support, and this is the bottom bar, and as well as the stirrup, which is the link, and this is the link area. This is the area controlling the link, and these are the top bar spacing. This is the spacing for the top bar. So anything you're having here is based on the spacing on the reinforcement. You can see, and this is the deflection check. So you can see that they are all sufficient. If they're not sufficient, they're going to pop up. This is going to pop up a red bar. But in the spacing, this is just trying to tell you that, when you're designing your concrete grade, at least you have a minimum of 20 cm so that the flow of your concrete can be able to pass through in between the ions. That's what this area is all about. So since we have two bar with this, size of beam, you can see a good numbers of spacing at this both the top bar and the bottom bar. So what we're going to do right now is to change this one so that we can have a minimum bar of 16 mm. Now I'll change it to 216 mm, two numbers of y16 mm, and you can see that it's failing. Under no condition, should I repeat myself? Under no condition should you allow this area showing this negative sign and the red text. Please, it should also look like this for it to be sufficient. So what you're going to do there is to increase the bar. So increasing the bar to 3y16 is still showing failure. So you increase it again, 4. With 4y16, you can see that the area is sufficient to carry such load, to carry such stress that is coming on this joint, to carry such strength. The hubble moment that is coming on this joint, this 4y16 is enough to take care of the hubble moment around this area, understand, at the joint. So this is sufficient. So on this area, now you can see we have red. So now if we have 31 spacing, is still because we are designing with a minimum of 20 millimeter spacing between the iron, between both iron. It should not exceed. If it exceeds 20, then it means it is advised that you should use a smaller size aggregate when you're doing your casting or your concrete pouring. Please take note of that, because this is what regulates those areas. So we having 30 is still beyond between our range of design. So I'm going to change this also to 16 mm. So if I change it to 16, you can see that I'm still having some failure here. So I have to increase the numbers of bar, maybe 3. So with 3, it is sufficient. So you can see that here too, you can see here, I'm going to reduce it. Reducing it is still failing, increase. You see, so with 3 bars here, the design is sufficient along that area. So we move and you check your reinforcement. So with this, you can see we getting 16 mm reinforcement. I think cost wise is a bit cheaper compared to you designing with 25 and 16 for your model. So you need to take note depending on the model you're doing. And when you're doing this, if you're having a bigger structure, versatile structure, please don't always reduce this to a very, very low cost, please. So you have to take note of the size, because there are some costs that are way beyond measures that you don't have to save. You have to let it be. You have to let it be. So you have to change the structural modification. We're going to check all of them. So you have to check this and edit this to suit your cost, to suit your cost, effect. So we're going to look at this. Why are we having such member? Are they the same? See, at this area we are still having 20. You can still increase it and you reduce. So it's still failing. We increase to 4. I guess that will pass. So at this area, what we're going to do, we're going to take, okay, let's increase to 4 and check. 20 is okay. So if we move to 16 and it's still failing, I guess you should just do what? You should just leave it at, you should leave it at, no, maybe increase it to 5 if you still want, or regarding, you can say 4, because by the time you say 4, you can see that we're having 19 here. So I don't want to do that. What I'm going to do is to increase to 20. I want to make it 20. If I have 20, it's still okay, and the spacing of my concrete, you can see it's okay. It's still above 20, and my deflection check are all okay. Deflection check. Now, in this area, because you do not see any space, any bar, any text here, does not mean it's failing. If this space is actually failing, it's going to indicate. So if you're not seeing any text there, the structure is still safe, you're still okay. So you have nothing to worry about this. So you go to click OK, and you can see clicking OK, you can see that turn it from 1 down to 90. So you're going to check all your material, taking note that you want to change them from 16 as the case may be. You're going to make sure that you satisfy and have a very good model as pleased as you want, as your intention. You have your choice to make when it comes to your interaction. You interact with the design, play with the design, tell the design your output, at a very good output. So after this, we are going to close. So we close, we take it back to the model. So now we are done with our modeling, with the building analysis, so and with the interactive design. So it's our time we move to our prota detail. So we're going to push this to AutoCAD where we can detail our output results proper. So we're going to click on concrete design. So when you click on concrete design, you click on load prota detail. So after loading this, it's going to save all the data and analysis, and it's going to export it down to our detail template. So there we're going to work on them. We're going to input them in the interface which we're going to export. So this is how the output results look like. You can see we have come over to our prota detail. So in detail prota detail, once you are here, you just click on start by creating a new drawing. So you click on this and you wait for it to load. You can see the interface. So on this interface, we'll just start by bringing in, exporting, drawing all our data here. You can start from the plan, you see, and click on the plan. You can see if you want to do it one after the other, you can do by creating one of them, but I just want to create it together. So and I'll draw here. You come over here and you click on draw. So when you click on draw, you click anywhere in the interface and you wait a while for it to process. So you can see right now it has finished processing. You can see it has generated all the flow together because I did not do it one after the other. I just draw it together. So moving to the column, so I can still do the same thing here, but in column, I want to generate, I want to generate my schedule. I don't want to draw the column because I don't like the way it looks like. So I just want to do this. So if you click on the table, but whereas we are going to do all, so click draw. So I'll click on this interface. So I like using this table to do my editing, but you can still view the column elevation. You can see. So we'll click anywhere on it. It's going to, you know, generate the column data for us. You can see this, but it is outlining on top of it. So I don't want it to be in this area. So I'm going to take note of that regard. I'm going to delete that one. So I've successfully take it out. Successfully I've taken it out. So I don't want it to be part of my model. So right now I'm going to go on the footing. So if I click on the footing, I'm going to draw footing. I don't want to draw one by one. I want to draw it together. You just click beam. On the beam, we'll do the same, but I don't want to draw all. I want to draw the beam one after the other. So I'll click on this, I'll right click and I'll say draw. So if I say draw, you click, just the same process, as simple as that. You can see it's going to wait. We're going to wait a while it draws. So that is the same process we are going to use in drawing all of them. The same procedure. You draw, come to any place and you click. You wait a while for it to load. So after this, we can now export it down to our AutoCAD. So we go to the last one, we click, same thing here, you draw. You can place it anywhere we like. It's still okay. Okay, so once you are done getting your parameters, it's very simple. You come here to export so that you can export these members down to what? Down to see, I can see some other column here that I did not delete. So what I'm going to do is to highlight them, and I'm going to delete those members now. I'm going to erase those former members that we have. So, for the purpose of this design, we can still, so you can see that I'm done taking them out. So since I have my plan, I have the plan elevation here. You can see this is the foundation, and this is the foundation detail. You can see this is the first floor, and the second, and the roof floor, and that are the beam respectively. And we have our, like I said, I like using the table to do my detailing. So when we get to detail, I will explain more about it. So right now, we're going to export. We're going to click on export so that we can export this drawing down to Autocad. So you click on this and you right click and you click export. So on drawing 3, you can also use any version of Autocad you want. The 2007, anyone you want, you can change it to any version you want. And after that, you just click what? Export. So you can see, you say there's another one here. So I want us to what? This file, override. No. Okay. So right here, you can just click on this drawing. Just look at it here. We've already exported it down to this place, no? So we're just going to click on it. So it's going to open right away. So you can see all the analysis and data that we've already done. So they are here. You can see each of them, each of the floors. See? So this is how you export your drawing. You can see all the various plans. You can see them and the footing. You see. So here we are.